Hey everybody, welcome back to another one of our videos. What we're going to be talking about here in this one is we're going to be talking about how to use our new spindle tramming tool. What this does is it allows us to load this tool into the spindle itself and touch down on our base plate and swing a nice large 8-inch circle and figure out how our nod and our tilt might be off on our machine. The nod and tilt is off at all. What that might do is it might leave ridges in your parts or in your base plate as you're trying to cut. So what we can do when we adjust the nod and tilt and tram everything in perfectly is make sure that when we cut with our tool, it creates a really nice, smooth, even surface. What you're going to want to do before you do any sort of tramming at all is you're going to make sure you go back and you do your Z alignment process. If you don't do that, and you do your tramming first, when you do your Z alignment, it's going to throw off your tram. And then you're going to have to do it again. So just go ahead, double check that your Z alignment is perfect, and then we'll move on and do some good tramming. What we have is we have the machine here in the upper position. So we have an upper position and we have a lower position for MR1. We recommend doing 95% of your cutting in the upper position and only going to the lower when you have to. The upper position just gives you much more clearance between your base plate and the tip of the tool. It's much more rigid as well. And if you do tram it in the lower position, whenever you move into the upper position, you're going to have to tram in the upper position again. So we recommend doing it in the upper position. So as far as tooling goes, I have various wrenches for making sure all the fasteners are off. And so that way we can take off the cover plate and we can take off the side plates. I have leftover shims from our assembly process. I like these really thin 0.05 millimeter shims. They make it really easy to get back behind all the spindle head surfaces and where we need. If you have just the bigger shims and maybe you're running low on these ones, what you can do is you can cut those big shims into small ribbons. Makes them much more manageable. If you did want to leave your spindle head in the upper position and cut your base plate, you can do both with our straight shank tool extension. What this does is it allows you to have your whole head of the machine in the upper and give your tool a little extra reach so that way you can get all the way down to the base plate. And you get the best of both worlds that way. After that, we come to our spindle tramming tool itself. What we're going to be doing with this tool is we're going to be coming down and touching off on the base plate and setting a 0 point with our dial indicator. We're going to start in the 6 o'clock position and swing it around to the 12 o'clock position, and we're going to figure out the difference between the 6 and the 12. That's going to tell us how far out the nod of our spindle is. After that, we're going to be able to know how many shims to add and where to add the shims in order to make that nod perfect. Next, we're going to be moving on to the tilt, coming down and touching off in the 9 o'clock position, and swinging it back around to the 3 o'clock position. That's going to tell us how far our tilt is off. To adjust the tilt, we have either the use of set screws in order to turn the tilt, or we can use just a soft blow hammer or a very soft metal hammer in order to nicely tap on our spindle block itself in order to bring in the tilt. So what we're going to do here is we're going to move on to actually taking out the spindle cover using our wrenches. Alright, I got my tramming tool loaded into the spindle here. What you can do is if you don't have a tramming tool, you can take the dovetail on the dial indicator and put it on the top of it. And then just load that whole thing into the spindle itself, and that'll allow you to swing a decent sized circle. Obviously it's not going to be as good as the tramming tool because you get that full 8-inch movement of the tramming tool, and that's really going to highlight the differences in your nod and your tilt and allow you to have much more accuracy when you're bringing in the head of your machine. So I'm going to go ahead, start taking my wrenches and start taking the cover of the machine off. So you have 2 screws on the side, each side of the machine, little ones that need to come off. And then you have 1 large screw on either side. So we're going to grab that. Okay. Now that we have our spindle cover off and loose, I'm just going to slide it up and out behind the gantry. That way it's just out of our way. When it's behind the gantry, it's not going to have to worry about anything getting hurt because we're not going to be moving the machine around much anyway. And I'll just let it hang there. Next, we have our 2 side gusset plates that need to come off. So there are 3 screws holding in the side gusset plates. Alright, our spindle cover is off, our side gusset plates are off. Now we can actually start moving the machine over and touch down on our base plate to start swinging our circle to see how far off our nod and our tilt are. I come around so I can see the face of my dial indicator, just so I can slowly bring it down until it just starts to touch off on the base plate. Alright, so I've just touched off. What I'm going to do now is I'm going to preload my dial by about 10 or 15 thousandths. It gives my dial plenty of movement to go either way, and that way I'm not going to run out of movement. Okay, got my dial indicator preloaded. I'm going to go ahead and set it to 0. And now we're going to swing it from the 6 o'clock position to the 12 o'clock position. Okay, so it looks like I have about 15 thousandths worth of difference between the 6 o'clock and the 12 o'clock position. So what my dial has done is it started off at 0 and it's gone counterclockwise all the way to 15. That means it's moved in a negative direction. So what that means for our nod and our tilt is that anytime you're moving in a clockwise position, it means that your tilt, or the nod of the machine, is digging down into the base plate, which is pushing the dial actually up, and that's going to swing it in a clockwise direction. So since this went in a counterclockwise direction, that means that it's not pushing down into the base plate, but it's swinging back up and going counterclockwise. So that means the nod of our spindle head here is tilting forward like this. So what that means is what we need to do is we need to add shims on the bottom of our block, which is going to swing the nod of our head back up to perfectly straight up and down. If your dial was moving in the clockwise direction from 6 to 12, that means that your nod of your head is actually doing this. And then you need to add shims to the top of the block, and that's going to push it back to perfectly straight up and down. So, how many shims to add? What you're going to be doing is you want to be either using a slight adjustment, a medium adjustment, or a large adjustment. And all that means is just slight is 1 shim on either side, medium is 2 shims, or a large adjustment is 3. I would consider 15 thousandths, probably about every 5 thousandths is the next quality of shims. And so what we're going to be doing here is we're going to be making a large adjustment. So I'm going to take 3 of these little shims. I'm going to put them on both sides at the bottom of the block. So that what you're going to be looking for is there's 2 of these large silver screws at the back of the block. What we want to do is we want to break those loose just enough so that way we can move the block itself and slide shims back behind it. And come around the other side and do the same thing. And now I got a little bit of play in the spindle block itself. That should be plenty enough for me to get shims behind it. So since we're doing a major adjustment, I'm going to grab 3 shims and just nicely slide it between the block and the plate itself. And I'm pushing back on the spindle head, that way I have enough clearance. Okay. And come around the other side and do the same thing. Alright, now that the shims are in place, we're going to want to tighten up these screws in the back here again. That way we're basically recreating the conditions that our final assembly is going to be in. And then we'll go ahead and we're going to sweep our 6 to 12 again to see how much more adjustment we need to make. I'm going to re-zero my indicator. Okay, so now we're looking at a difference of 7 thousandths. So that means for our 3 shims that we put in there, we've gone about half the distance that we needed to. An alternative way to do this, if you make it a little bit easier for you, is what you can do is you can try to split the difference in your 6 o'clock position and your 12 o'clock position. So right now, this is reading 7, and this is reading 0. What I can do is I can adjust the height of my spindle. So that way it splits the difference. So that way half of the indicator is being read here, and the other half is being read there. So what I'm going to do is I'm going to drop this down to about 3.5 thousandths. So that way when I swing my indicator back to the front, this is reading 3.5 thousandths in the other direction. That way I know I'm trying to adjust towards 0 rather than trying to adjust towards some arbitrary number. So if I'm going to my 0 position, I know I need to move just probably the same amount I did last time, seeing as how we got halfway to our goal. So what I'm going to do is I'm going to take 3 more shims, add them to the block, and we'll see if we're a lot closer to our 0 point or not. Okay, just like last time, back to 6 o'clock. We're going to re-zero our indicator, see where we're at. Alright, looks like we still got about 3 thousandths to go. What we're going to do is, this is just a smaller adjustment to make, so I'm just going to put 2 shims on either side now, and we're going to see where we're at. Hopefully, 3rd time's charm. Alright, there we go. So what we do is we have a tolerance about 1 thousandths when it comes to this indicator. You know, 1 thousandths over 8 inches. That's very, very good for making sure that when you cut across your base plate or when you're cutting across your part, you're going to have very, very faint lines, if any. So we're within 1, so I'm going to call that good for our nod. That means we can go ahead and start moving on to our tilt. Okay, we've got our nod perfect, front to back, so now we're going to be moving on to the tilt, side to side. So just like the front, all I did is I brought this down until it's touching off, and I went ahead and zeroed it out. And now we're going to be sweeping it from the 9 o'clock position to the 3 o'clock position. So take a look here. So we're at -5. So that means that, again, when we do our sweeping motion, we're seeing that it's moving in a counterclockwise this way. That means that as it's coming along, it's being pushed down farther end, from the further end on our 9 o'clock, and it's coming up in our 3 o'clock position. Which means that the whole head of our machine here is tilted counterclockwise. So we're going to want to tilt it back clockwise. In order to do that, we're going to take a look at our gusset plates, and we're going to see if we have set screws in here or not. Not all machines will have set screws. If you do, we're going to be using those set screws in order to rotate our whole spindle head clockwise. So if we want to move it in the clockwise position, what we're going to be doing is we're going to be adjusting the bottom right set screw and the top left set screw, and we're going to be pushing both of those in order to turn it, the whole thing, clockwise. If you don't have set screws, that's totally fine. What you can do is you can use shims instead. So rather than turning set screws, you're just be adding shims in order to rotate the whole head of the machine. So all I'm going to do is I'm going to move back to my 9 o'clock position. You see my 0 point, and then I'm going to come through with my wrench and begin tightening my bottom right. So all I'm going to do here is I'm going to rotate this wrench and watch my dial, so that way it's moving in a counterclockwise direction. what I want to be doing is I want to be chasing the other side of the part. So if this is -5 over here, I'm going to want to make sure that my dial is moving it in the negative direction. So I'm going to go ahead, I'm going to tighten up the bottom right and the top left in order to clock it back clockwise. And I'm going to make sure that all of that is perfectly even. Once I do that, I'm going to take my time, make sure everything is perfect, and then go ahead and tighten everything back up. Alright, what I'm going to be doing to bring in the last 5 thousandths is I'm going to be using a soft blow hammer. That way, if I have a really large adjustment to make, I can use the hammer to quickly bring it in. Or if you don't have self-adjustment screws, set screws, you can use a hammer instead. So I know the head of my spindle is still tilted in the counterclockwise direction. So what I want to do is I want to strike on the bottom of the block here in order to bring it back to clockwise. So I'm going to bring it around. That way I can see my dial and see about how far I need to go. I know that I have about 5 thousandths of a difference between each side. So what I'm going to do here is I'm going to strike the bottom of the block until I move about 2.5 thousandths. Alright, let's check that. Perfect. Alright, that's great. So now that we're bringing in the tilt, what we're going to do is we're going to tighten up our screws in the back again and double check our dial. Alright, so our dial's within thousandths now. Now that we have both our nod and our tilt within thousandths, we're all set to continue and leave it in our upper position, so that way we know all of our parts are going to be perfect. If we want to cut in the lower position, we can use our straight shank extension tool to get down to our base plate, and we're all set. So, thanks for watching. Stick with it. If you have any questions, let us know, and I'll see you in the next one.